Okay, boys and girls, we are going to be doing our video lesson again tonight. Now, what I need you guys to do is open up your notes, but this time I want you guys to flip all the way to it says 4-5 equivalent fractions. We're going to skip 2 lessons. We'll come back to them next week. So, find where it says equivalent fractions, open up your notes packet. I'm going to begin the lesson. Again, pause if you need to in order to write down what we're doing. So when we're talking about equivalent fractions, before we begin that, let's begin with a quick review and recap of what are fractions. A fraction is a number that expresses a part of a group. So fractions are written in this form. If I have 1/6, the top number is called the numerator and the bottom number is called the denominator. So that means I have 1 out of 6 pieces. So again, that's just kind of quickly what fractions are. What we're talking about today specifically are what are equivalent fractions. So under the top of your page, you should see this question written down. In the lines below it, let's fill this in. So where it says, what are equivalent fractions? Let's write in the lines, equivalent fractions are different fractions which name the same amount. So again, find where it says, what are equivalent fractions, and copy down the sentence. Equivalent fractions are different fractions which name the same amount. Keep writing that down. Okay. I have some examples on my board that 1/2 of the first circle is red and 3/6 of the second circle is red. Those are equivalent fractions since they technically are equal amounts. So 1/2 and 3/6 are equivalent fractions. If you have not finished writing down that sentence, pause the video, finish writing it down, and then unpause it because I'm going to move on to the next slide right now. So equivalent fractions name the same amount. So next question is, how do you find an equivalent fraction? So under the second question on there, let's write down, you multiply or divide the numerator and denominator by the same number. Multiply or divide the numerator and denominator by the same number. Again, you should be writing this down where it says, how do you find an equivalent fraction? Write this on the lines below it. I'm going to keep going. You should not have probably finished writing it down by now, but pause the video. Unpause it after you write down the sentence, multiply or divide the numerator and denominator by the same number. We're going to do some examples here on the next slide that you're going to jot down with me as well. So I moved on. If you did not finish writing that last definition, please rewind the video a little bit, kind of drag it backwards so you can get that sentence written down, and then pause it till you have it done. So again, we're going to talk about equivalent fractions. So we just wrote down that we multiply or divide the numerator and denominator by the same number. So when I look at not 1/2 there, I could multiply or divide 1/2 by any number to find an equivalent fraction. I could do 1/2 times 3 on the top and bottom and get an equivalent fraction of 3/6 like we did in that first example. When I look at all of my numbers here, I have 2/3, 2/4, 3/4, and 4/5. When I look at it, it looks like 1/2 is going to be equivalent to 2/4. So 1 times 2 is 2, and 2 times 2 is 4. Because I multiplied top and bottom by that same number, I end up getting an equivalent fraction. Now let's look at 2/3. I can multiply this by any number I want. I can multiply 2 times 4 and 3 times 4. Again, it's multiplying the top and bottom by that same number to get an equivalent fraction. 2 times 4 is 8. 3 times 4 is 12. So 8/12 would be an equivalent fraction to 2/3. I can find many equivalent fractions. Let's look at my answer choices down here though. If I have something like 6/4, I would multiply 2 times 3 to equal 6, and I would do 3 times 2 to equal 4. Did I multiply numerator and denominator by the same fraction? I hope you're saying no, because that means it is not an equivalent fraction. So that one wouldn't work. However, if I do 4/6, do you notice that 2 times 2 equals 4 and 3 times 2 equals 6? So again, I use the same number on the top and bottom to get to my equivalent fraction. So we have one last thing to talk about, is how do you simplify fractions? We want to write fractions using the smallest numbers possible. That's what simplify means. Simplify means to make it smaller. So underneath the question, we're going to write what's in this box right here. So how do you simplify fractions? You divide the top and bottom by the same number. So let's write that one sentence down under question 3. How do you simplify fractions? Again, Yours I think says how do you reduce fractions? Reduce and simplify are the same thing. So under question 3, let's write down divide top and bottom by the same number. Pause the video until you finish writing it, unpause it to join back up with the video. So when I'm looking at this, I need to figure out, well, what are numbers that can go into both the numerator and the denominator? We can use our divisibility rules to help us figure out what some numbers are. So if I have my example of 27 over 108, those are some big numbers. However, I remember that 2 plus 9, or 2 plus 7 equals 9, gave away the answer there, and 1 plus 0 plus 8 equals 9. So I know that 9 can go into both my top and my bottom number. So I can simplify it down to 9 over 36. However, 9 can also go into 9 and 36, so I have to divide them again. Let's practice some examples with some smaller numbers right now. So when I have this, if I have 6 over 22, let's jot this one down. I need to think about what's a number that can go into both 6 and 22. I know that they're both even, so both of them are divisible by 2. So let's write down 6 divided by 2 and 22 divided by 2, because again, I have to divide the top and bottom by that same number. So 6 divided by 2 is 3, 22 divided by 2 is 11. So 6 over 22 equals 3 over 11. Is there anything else that can go into both 3 and 11? I don't think so, because they're both prime, so I do get 3 11ths as my answer. Let's look at number 3 next. I'm going to go down below it. If I have 5 tenths, what can go into both 5 and 10? Well, again, thinking back to my divisibility rules, I know that 5 can go into both 5 and 10. So 5 divided by 5 is 1, and 10 divided by 5 is 2. That would simplify down to 1/2. Now number 2 I skipped here for a minute because that one's a little tricky. If I have 6 over 13, I have to think about what numbers can go into 6 and what numbers can go into 13. Do they have any of the same numbers in common? They only have 1 in common, and dividing by 1 won't do anything. So number 2, 6 over 13, actually cannot be simplified. That would stay 6/13. Okay, we're going to move on to one last thing. This is what we're going to be doing a lot in class tomorrow. Sometimes you're going to see fractions, and you have to figure out, well, what's the missing number? So if I have 2/3, I want to figure out, well, how many 18ths is that? So I need to think about, what am I going to do to 3 to turn it into an 18? Well, I know that 3 times 6 equals 18. Because it's an equivalent fraction that I want to find, whatever I do to the bottom, I have to do the same thing to the top. So 2 times 6 is 12. So you should put 12 in that missing box. Let's look at our one last problem for today's lesson. I have 70 over 100, and I want to know how many 7s is that? Well, I know that they both end in zeros, and I know from my divisibility rules that that means that I can divide them both by 10. So let's see if that works. 70 divided by 10 equals 7. So that ends up working out. Since I divided by 10 on the top, what should I do on the bottom? I hope in your head you just answered me saying divide by 10. So I would divide top and bottom again by the same number. 100 divided by 10 is 10. So 7/10 would be my equivalent fraction. So that's kind of how we do equivalent fractions. We're going to practice this more in class tomorrow with a very fun app.